Hey, welcome back everybody. We are back to our study of probability, and hopefully you remember these words from yesterday and you already have them in your vocabulary notebook. Um, Today the most important thing we're learning about is the difference between independent events and dependent events. Now we learned yesterday that independent events are events where the occurrence of one event does not affect the probability of the occurrence of the other. For example, if my first event is to roll a die, and my second event is to roll a die again, those are independent events. What happened the first time did not affect what happened the second time. The first time I rolled a 4, the second time I still could have rolled a 1, 2, 3, 4, 5, or 6. It made no difference. That's an example of an independent event. Only one word to define today. If you haven't guessed it yet, it is dependent events. Dependent events are events where the outcome of one event affects the probability of occurrence of the other event. Go ahead and write that down. And if you need more time, go ahead and pause the video momentarily. Okay, so what's an example of a dependent event? Well, let's say I have my 3 cards again, okay? Jack, Queen, and King. This time my 2 events are going to be to mix them up, draw a card, take that card out of the deck, then mix up the remaining cards and draw another card. So let me show you what I'm talking about. We have 3 cards here. I'm going to mix them up randomly. And you know that the probability of me picking any particular one of these cards is 1 out of 3. There's a 1/3 probability I'll pick a Jack, 1/3 for Queen, 1/3 for King. So let me go ahead and draw one randomly. I get a Jack. Okay? Now I'm going to get rid of that Jack. I'm going to draw again. As you can see, the probability of getting another card now has changed, because instead of there being 3 cards here, I only have 2 left. So instead of the probability of getting any particular card being 1 out of 3, it's 1 out of 2 for the 2 remaining cards. So it mattered what happened at first. Not to mention, if I were to say, what is the probability of getting a Jack? Well, now there's no probability of getting a Jack, because all that's left is the King and Queen. So the fact that the Jack was thrown out definitely changed the probability of getting a Jack, a Queen, or a King. So that's an example of a dependent event. Okay, so here's another example. You see inside this cup I have 4 paper clips, 3 reds and a black. So the probability of randomly drawing the black one is 1 out of 4. Okay. So I'm going to go ahead and shake these up. I'm going to reach in and pull one out randomly, and I got the red one. Okay, makes sense. Now if I were to put the red one back in and do it again, my probability of getting a black is still 1 out of 4. So those would be independent events. It wouldn't matter. But if I took the one that I pulled, I'll go ahead and do it again. I'll shake them up, I'll reach in, pull one out randomly. I got a red one, okay? Now if I don't put it back in, if I instead throw it away, okay, and then I do it again, now you can see there's only 3 paper clips left in there. So now my probability of black has become 1 out of 3, okay? So the probability has now changed, so the outcome of one event has changed the probability of the second event. Not to mention, what if I had drawn a black one the first time and thrown it away? Well, then there's no way I could have drawn another black one, because it would be gone. And now my chance of getting a black one would be 0 on the second event. So that's an example of a dependent event. Alrighty. Let's pick another scenario here, okay? We have a situation here. You have to decide if it's a dependent or independent, if they're dependent or independent events. So Ralph and Sam pick out seats in the movie theater. Ralph picks first, then it's Sam's turn. Go ahead and take a guess. Independent or dependent? Okay, hopefully you picked dependent, because once Ralph picks a seat, there are fewer seats for Sam to pick from. In other words, let's say there's 100 seats in the movie theater, okay? The odds of Ralph picking any one particular seat is 1 out of 100, all right? But then, when Sam goes to pick, there's only 99 possible seats, all right? So the odds don't change a whole lot, but they change a little bit, and that's why it is a dependent event. All right, time for another one. Students in a classroom are voting for class president by secret ballot. Jeff submits a ballot, and then Jake does. Are those events independent or dependent? Hopefully you chose independent. Because it doesn't matter who Jeff voted for, Jake can still vote for the same number of people. So the odds don't change. The probability of him choosing one or the other doesn't change. Independent. Last one. Mr. Gilmore's students are picking slips of paper numbered 1 to 20 to determine the order reports will be given. Eve picks her number first, then Amy picks a number. What do you think? Dependent or independent? Okay, well, when Eve picks her number, she could pick 1 out of any of the 20. But once she's picked that 1, that number is gone. So when Amy picks, there's only 19 left. All right, so it has changed her odds. And if Eve picked number 1, then Amy can't get number 1. So that's the first event affected the second event. That's all you have to do today, is know the difference between independent and dependent events. Good luck.